In this video, we're going to start our first type of function. So the first part of the Heart of Algebra was just an introduction to functions, how to graph them. For the rest
of the Heart of Algebra, and then in our next section that we're going to do, we're going to be looking at types of functions. So the simplest type of function would be a linear function. So let's go right into that definition. So it says a linear function is a function of the form f of x equals mx plus b, where m and b are real numbers. Okay, so this m and b can be anything as long as they're real, and then you'll see an x here. You can also write it like this, y equals mx plus b. Okay, so notice that x is the input value. Okay, also you have this x inside the parentheses, and y is the output, or f of x. So you will have a point x as an input, f of x as your output, x as an input, y as your output. Okay, so either one of those is correct. The graph of a linear function is a line. Okay, so this is going to be true for as long as you see this a linear function, you can automatically say it's a line. Okay, so once you've picked out that a function or equation or an equation is a linear function or linear equation, you know it has to be a line. So it looks something like this maybe, or it looks something like this maybe. It could also look something like this. Okay, so once you've picked out that a function or an equation is a line, it's going to look like this, this, or this. It could also be a vertical line. Okay, but this is not a function. Okay, it fails the vertical line test. Okay, so if you take a vertical line on the vertical line, it hits it an infinite amount of points. Okay, so it fails that vertical line test, so that's not a function. Okay, it is a line, but it's not a function. So we'll come back to what that looks like in a little bit. Okay, so example, it says, are the following functions linear? Number 1, f of x equals 3x plus 2. So is it in this form? Yes, it's actually exactly in that form. Okay, so let's just go ahead and write out what m is. So m, you can see, is the number attached to the x value. Okay, so in this case, m would be 3. And b is 2, so the constant. It's a little bright. Let me turn this down a little bit. Number 2, g of x equals 3x squared plus 1. Okay, this is not a linear function because of this x squared. Okay, it can just have an x here. So this would be no because of the x squared. So this is a different type of function that we're going to look at in the next section. Number 3, h of x equals square root of 2 minus 4x. Okay, this is a linear function. The number attached to the x value would be negative 4. And then b, the constant, is the square root of 2. Okay, that is a real number. Okay, it's approximately 1.41. Number 4, s of t equals t minus 1. This is a linear function. It doesn't matter what variable you have as your input. So here the input would be t. M, which is the number attached to the variable, would be 1, so there's an imaginary 1 there. B is negative 1. Number 5, v of t equals 1 over t. This is not linear, okay, because you have a t in the denominator. Okay, so this is not linear. Here, notice it's not in a denominator. Number 6, h of t equals 1 minus 5t over 4. This is linear. Notice the variable is not in the denominator, so it's fine. To see this, let's go ahead and break this up. So you can break up a numerator. Okay, so this would be 1/4, so 1 divided by 4 minus 5t divided by 4. Okay, so now you can probably see better that this is a linear function. So m, which is the number attached to the variable, would be negative 5/4, and then b is 1/4. Number 7, w of t equals 6t. This is linear. Okay, you might say, well, it's missing the b. Okay, but you can always add 0, right? Same type, it's same function. If you add 0, you haven't changed it. So here m would be 6, b would be 0. And then number 8, k of s equals 3. Okay, again,
You might say, well, it's missing the variable altogether, but you can add in 0t, right? So 3 plus 0t is still just 3, so you haven't changed the function. So here m would be 0 and b is 3. Okay, remember that this is a constant function. We've drawn this before with an xy chart. This is a constant function. Remember, it looks like this. Okay, so all your horizontal lines are going to look something like this. So f of x equals 8, or f of x equals 100. Okay, so anytime you just have a number, your slope is 0, it's going to be a horizontal line through that number. Okay, next definition, the slope of a line is the ratio of rise to run. So we've got a couple definitions here for slope. So slope is the same as rise over run. Rise meaning the change in vertical height, run meaning the change in horizontal height. Okay, it's the same as change in y divided by change in x, if you'd rather remember it like that, which is also the same as if you have 2 points, you can do the y's minus the y divided by the x minus another x. So just remember, I like to remember rise over run. Okay, also this one is good to know, just in case you're given 2 points. Okay, we're going to look at the slope more on the next page. We need to do a couple more definitions. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. Okay, so if you have some graph here, this point here is where the graph is crossing the y-axis. This would be the y-intercept. And this point here is where the graph crosses the x-axis, so this would be the x-intercept. Okay, this is really important. Okay, we're going to use this over and over again. It says for the linear function f of x equals mx plus b or b plus mx, the slope is m and the y-intercept is b. Okay, so all of these linear functions that we wrote up here, we picked out the m, we picked out the b, we know the slope, we know the y-intercept. We don't have to do any work there. So for example, this m equals 3, b equals 2, we know the slope is 3, y-intercept is 2. Okay, so we're going to do some examples with that, and then we're going to use those to graph. Okay, page 18. It says consider the function f of x equals 2x plus 4. Find the slope of f. Okay, so we know the slope is just m, okay, which is the number attached to the variable, which is 2. Find the y-intercept of f. Okay, so that is b equals, here it's 4. Okay, what point do we know we have on the graph of f, I'm sorry. Okay, so we know that b is the y-intercept. Okay, so that's this point here. Okay, so the x is 0, the y would be the b point. Okay, so we would have 0, 4 here. Okay, so the y-intercept is 0, b, always. Okay, and then number 3, it says using the slope and y-intercept graph the function. Okay, so let's go ahead and just graph this point that we know is on our function. I'm going to start lower here since we have to go up to 4. Went up 8 over 3 each way on the x is perfectly fine. Okay, so go up 4, 1, 2, 3, 4. Here's our y-intercept. So this is where our line is going to cross. Okay, our slope is 2. Okay, so notice our slope is rise over run. Okay, so it's always a fraction, which we can easily make 2 into a fraction. So it's the same as 2 over 1. Okay, and I'm just going to write that this is rise over run. Okay, so from this point we can get to a new point using our slope. So the slope says to get to the next point you need to go up 2, rise 2, run 1. Okay, I went up because 2 was positive. I went to the right because 1 was positive. Connect 2 points and there's our line. Okay, so 2x plus 4 looks exactly like this. Okay, we didn't use an xy chart, we didn't use our calculator. Next, to consider the equation y equals negative 3 minus x. Find the slope of the line. Okay, so the slope is the number attached to the variable, so that is m, which is negative 1. Okay, there's a negative 1 there. Find the y-intercept of the line. B would be negative 3, so we're going to graph 0, negative 3. That's our y-intercept. Using the slope and y-intercept, graph the equation. Okay, so let's go ahead. I've got more room here, so I'm going to do more points. Okay, so 0, negative 3, there's our y-intercept. Okay, our slope is -1. Again, I'm going to make this into a fraction, so -1 divided by 1, okay, which is the same as rise over run since this is our slope. Okay, notice one of these is negative. Okay, so our rise is -1, which means we need to go down 1. Okay, our run is positive, so we're still going to go to the right 1. If you took this -1 and you wrote this as 1 divided by -1, because that's still -1, you're gonna get a different, you're still going to get the same line. Okay, so as long as you have one of them being negative. Okay, so there's the graph of that line. Okay, page 19, we're going to do one more. It's a little different. So it says, consider the equation 2x plus 3y equals -6. Find the slope of the line. Okay, so before we can write out the slope, we need to solve for y first. Okay, you can't just say there's a 2 in front of the x. Okay, because it's not solved for y. What would the y-intercept be? You can't say it's -6 because there's this 3y here. Okay, so we're going to solve for y first. So I'm just going to come up here, 2x plus 3y equals -6. So I'm trying to get, oh, sorry, you can't see that. I'm trying to get y by itself. Okay, so we're going to subtract 2x on both sides. So we have 3y equals -6 minus 2x. Okay, and then divide by 3 to get y by itself. Okay, so once you divide by 3, I'm going to go ahead and break this up. So this is -6 divided by 3. Is what, -2? So -2, and then we have -2 divided by 3, so I'm just going to leave that as -2/3, and then there's an x here. Okay, so there's our line. Okay, we didn't change this equation at all, we just made it look different. Okay, so instead of solving for this -6, we have solved for y here. Okay, so now we can easily pick out the slope, which is -2/3, so m equals -2/3. B would be -2, which I should have put B here. So B equals -2. So we have the point 0, -2. Okay, so let's go ahead and graph this. Okay, so we're going to graph 0, -2. Okay, now we have -2/3. So I'm just going to write rise over run since it's already a fraction. Okay, I'm going to use my -2 as being negative. 3 is positive. Now you can do it the other way around. You could do 2 positive, 3 negative. As long as one of them is negative, it makes the whole thing negative. Okay, so I'm going to use my rise as -2. So I'm going to go down 2 and then run 3. 1, 2, 3. Okay, so if you did, let's instead you said 2 over -3, you would have went up 2 and then to the left 3, okay, which is not lining up perfectly here. So you'd have a different point, but it's still the same line. Okay, next example, it says find the slope between the points 1, 0 and 2, 3. Okay, so there's a couple ways we can do this. Let's go ahead and graph the points, and we'll just do rise over run. We'll also use, just to give you another example, the equation for slope. Okay, so to graph this, we have 1, 0, then we also have 2, 3. So I'm just putting in the points we need here. Okay, so slope is rise over run. So to get from here to here, we rise 1, 2, 3, and then run over 1, and these are all positive, so the slope would be 3 here. Okay, now just to check this, if you look back on our definition of slope, it was y2 minus y1 over x2 minus x1. Okay, notice this is change in the vertical, change in horizontal. Okay, so we already did that, change in vertical, change in horizontal. Okay, I don't suggest using this just because it's going to be harder to memorize. Okay, so if you just remember slope is rise over run, I think that's the easiest way to remember. Okay, so y2, so this is subtracting the y, so I'm going to go ahead and make this y2, so this would be 3 minus y1, which is 0, so just subtracting the y's. Now I'm subtracting the x's, 2 minus 1. Okay, so that is 3 over 1, which is 3, which is exactly what we had. Okay, so either way works. If you want to memorize this, that's perfectly fine. Okay, but just remember it's rise over run. Okay, next example says find the slope of the line in the graph below. Okay, so I'm going to go ahead and draw in 2 points with a line. Okay, so out 5, up 4 is all we need. I'm going to have this point here, so this is 5, 1, 1, 2, 3, 4, 5. And then I'm going to do 2, 4. Okay, so we could do this exactly, and we're going to do this exactly how we just did the previous problem, which I'm just going to use rise over run. Okay, so n is rise over run. So what's the change in the vertical height? So from 1 to 4. So from 1 to 4, you need to go 1, 2, 3. And then run. So we're going from 5 to 2. So 1, 2, 3. Okay, notice this is negative since we went backwards. Okay, so we went up. Okay, so that was positive, and then when you go backwards, it's negative. Okay, now if you went from this point to this point, okay, the rise would have been negative, and then the run would have been positive, which is still going, so it would have been negative 3 over 3, which is still negative 1. Okay, so it doesn't matter which point you go from. Okay, just keep track of your positives and your negatives. Okay, bottom of page 19, this is important. It says lines can have positive slope, negative slope, a slope of 0, or undefined slope. Okay, so positive slope, we've graphed something like that, which let me look back to page 18. Okay, this was positive slope, m was 2. Okay, and you have that this line is increasing. Okay, so positive slope, you have an increasing line. So I'm going to put m greater than 0. Negative slope, which was actually all the other lines we had, okay, you have a decreasing line, so something like this, so m less than 0. Slope equal to 0, you're going to have a horizontal line, okay, which we already went over that. Okay, so you're not going to have an x value, so your line is going to look, or your equation is going to look something like this, y equals b, so it's going to be y equals 4, y equals negative 20. Okay, it's a horizontal line. And it says undefined slope, which I'm going to go ahead and just switch to a new piece of paper so we have room here. Undefined slope would be a vertical line. Okay, so why is this undefined? So let's say we're going from this point to this point. Okay, m is rise over run. Okay, rise, it would be maybe 1, 2. And then what's the run from here to here? It was 0, right? Okay, that's undefined. So vertical lines have undefined slope. Their equations look like this. X equals, we could do b again. Okay, so notice there's no y here, it's x equals. Okay, so this is vertical line, and this is undefined slope. Okay, so that is the end of page 19. Let's go ahead and look at a couple ways to write out lines on page 20. So it says the definition of the slope-intercept form of the equation of a line is y equals mx plus b, where the slope is m and y-intercept is b. We've already seen this, mx plus b, y equals mx plus b. Okay, but we don't have a name for it yet. Okay, so it's called the slope-intercept form, and that's because the slope is given to you and the intercept is given to you. Okay, so slope-intercept, because those two things are given to you. Okay, so it says find an equation of the line with slope 3 and y-intercept negative 2. Okay, so that would be y equals, slope is 3, so 3x, y-intercept negative 2, so minus 2. That's all you have to do. Next example, find the slope and y-intercept of the line with the equation 2x plus 3y equals 4. Okay, again, don't just say that the slope is 2, okay, because you have to have it solved for y. It has to be in this form, y equals. Okay, so we have to solve for y first. So we have 2x plus 3y equals 4. We're getting y by itself, so subtract 2x on both sides. So 3y equals 4 minus 2x. And then the last step is to divide by 2x, sorry. Okay, so that cancels. So we have y equals, I'm going to divide out. This would be 4 divided by 3, I'm just going to leave it like that, minus 2 divided by 3x. Okay, so this slope would be negative 2/3. The y-intercept b would be 4/3. Okay, so be careful if it's not given to you as y equals, you need to go ahead and make it into y equals. Next definition, the point-slope form of the equation of a line that passes through the point x1, y1 and has slope m is y minus y1 equals m times x minus x1. Okay, so now we have a different way of writing a line. Okay, it's called the point-slope form because you're given a point, x1, y1, and you're given a slope. Okay, so first example is find an equation of the line passing through 1, negative 3 with slope negative 1/2. So we're just going to follow this. Okay, so we have y minus the y of the point, which is negative 3, equals m, which we have the slope is negative 1/2, times x minus the x of the point, which is 1. Okay, let's go ahead and simplify this. I don't like leaving it in this form. Okay, this form is helpful when we're given a point and a slope, okay, but leaving it in this form is just kind of messy. So we have y plus 3, this changes to y plus 3, equals, I'm going to go ahead and distribute the 1/2. So negative 1/2 x plus 1/2. Okay, now subtract 3 on both sides. So this would be negative 1/2 x. So this would be minus, so because we're subtracting 3 here, minus 2.5, so I'm just going to put negative 2.5, sorry. Okay, so there's our equation. Okay, technically this is an equation of a line. Like I said, it just looks messy. Okay, next example, find an equation of the line passing through points negative 1, 2, and 3, 4. Okay, so you can see that we have a point, so we're probably going to use point slope form, okay, but we don't have a slope, but we can easily find the slope. Okay, so I'm just going to go ahead and use the y2 minus y1 since we haven't used that. I don't want to graph these points either. Okay, so y2, I'm just going to say that 2's are here, the 1's are here. So it's y minus the y, so 4 minus 2. So this would
be 2 over 4, which is 1/2. So there's our slope. Slope is 1/2. Okay, now we can go through, use our point slope form because we have a point and we have the slope. Okay, so I'm just going to use this point. You could use this point, it'll still give you the same line. So you have y minus the y value, which is 2, equals the slope, 1/2, times x minus the x value, which is negative 1. Okay, again, I'm going to simplify because it looks messy. So this is 1/2 times x plus 1. Go ahead and distribute the 1/2. Y minus 2 equals 1/2 x plus 1/2. Come up over here. We're adding 2 now to solve for y. Y equals 1/2 x plus 2.5. So that's very close to the one we just had. Okay, so we were not given the slope here, but we can easily find it given 2 points, and then we can find our slope and y-intercept now because we have it in slope-intercept form. Okay, next example, find an equation of the line passing through the points 0, 5, and negative 2, negative 6. So same type of problem. I'm going to find the slope first. So I'm going to do y minus y first. So minus 6 minus 5 over negative 2 minus 0, sorry. Okay, negative 6 minus 5 is negative 11 over negative 2, so the slope is 11/2. Okay, so we could go through and do y minus the y equals m times x minus the x using this point slope form because now we have the slope and then we have a point, so use one of those. But notice this is 0, 5. This is the y-intercept. So we actually have slope-intercept form. Okay, so this is just something to notice. If you do it exactly like this previous example, you're going to get the exact same answer. Okay, this is just a little shortcut. So y equals mx plus b. Okay, so y equals m, which we know is 11/2 x, plus b, which we have 5 here.
Okay, so slope-intercept form definitely needs to be memorized. I would also memorize this point-slope form. Okay, so both of these forms I would memorize for the exam, especially slope-intercept. You're going to see that one over and over again. Okay, page 21. Okay, this is extra. If you do not have a graphing calculator, go ahead and stop the video. You don't need this. If you do have a graphing calculator, this would be something really nice to know if you're given tables or a scatter plot. Okay, so this says finding linear regression in your calculator. All right, so what does linear regression mean? So what we're going to do is we're going to take information here. So these are points. So someone actually went out and got this data. Okay, and we're going to go ahead and graph this. So I'm just going to go ahead and do that now. So I'm going to graph this. It says the table below is the U.S. infant mortality rate for certain years. Find the regression line for that data. So I'm going to explain what this regression line is in a second. It says use x equals 0 for the year 1950. Okay, so getting out your calculator, I'm going to go ahead and turn this on. We have graphed the scatter plot with this before. Okay, so if you don't remember how to graph scatter plots with your calculator, go back to our very first video. It was the Heart of Algebra Part 1. Okay, so you go to Stat, go ahead and press Enter. We're already on Edit. I already have these points in here. Okay, so 1950 is year 0, 60 would be 10, 20, 30, all the way to 50. Okay, and then I have all the points in there. Okay, go ahead and turn your stat plot on, which I believe mine still is on, yes. Window, we need to go from 0 to 50, and then 0 to 30 would be fine for the y's. Also go into y equals, make sure all of your graphs are cleared out, which I'm going to clear that out, and graph. Okay, so I'm going to go ahead and copy this picture. Actually, we have down here sketch a scatter plot. So we did 0 to 50 for the x and 0 to 30 here. I'm just copying these down. Okay, you could have easily done this by hand. It's just a lot faster and more accurate. Okay, so there's our scatter plot for those points. Okay, what does linear regression mean? So finding a regression line is trying to find a line that best fits this data. Okay, so you can see that it looks like it almost goes through these 3 points. Okay, but it's going to miss these 2 points. Okay, so instead, should we go through these 2 points and miss these 3 points? Or should we use this point? Okay, so your calculator can figure this for you very quickly. Okay, so going back up here, I'm going to go ahead and write out the steps. Okay, so you're going to go to Stat, Edit, okay, which we did, and then we're going to put in values. Okay, so we've already done that. We've done this before. Okay, so we went over that quickly. Now to find regression, we're going to go back to Stat. Okay, this time we're going to go over to Calculate. Okay, then we're going to find linear regression, which on mine is number 4. It may not be that for yours, so I just use the first one. Linear regression, ax plus b. Okay, press Enter. And then make sure your list 1 is the x, list 2 is the y. Okay, if you put it in 3 and 4, then you would want to change list x list to list 3, y list to 4. The L1 and L2, they're under 1 and 2, so you would do second. So let's say I want to change the x list to L3. I would change it to second L3. Okay, so you can see that, which I want at list 1 because that's where I have my x's. I'm actually going to clear that so you can see there. Okay, so my version you just need to calculate through. Okay, and it gives you y equals ax plus b, so a is the slope, b is the y-intercept, and it says a, which I'm going to do approximate versions, is 0.48 approximately. B is approximately 29.41. You don't have this r squared and r. Okay, you have to turn the diagnostic on for that. Don't worry about that for the SAT. You don't need to know that. And that's just a way of telling you how accurate the line is, which you don't need that. Okay, so there's our regression line for this data, which I should have wrote it here. Okay, so I'm just going to copy this down here, except I'm going to write it in the y equals. So y equals a, which is negative 0.48x, plus b, which is 29.41. So there's our regression line. Okay, let's go ahead and graph this line. Okay, make sure it's accurate. Before I move on, if you have an older version, which I forgot to tell you this, so you would have went to stat over to calculate, enter here, and what your home screen would look like, it wouldn't look like that. It's going to say linear regression, ax plus b, and then it's probably just flashing. It might have an open parentheses, I'm not really sure. What you'll do is you'll type in L1, comma L2, okay, or whatever your list is. So if you did it in 3 and 4, you would do L3, comma L4. Okay, make sure you close your parentheses, then press enter. You should get the same numbers out. Okay, so I'm going to graph this line, make sure it looks accurate. So y equals negative 0.48x plus 29.41. So I'm going to graph this over my scatter plot. And you can see that looks like it fits the line or the points pretty well. Okay, so I'm going to try to graph this as best as I can. So it looks like it goes through above this one, below this one. Okay, my points aren't perfect, but something like that. Okay, and then number 2, it says estimate the infant mortality rate in 1995. So that would be x equals, okay, 90 was 10, 20, 30, 40, 0, 10, 20, 30, 40. So x would be 45 since it was 95. Okay, so we're just going to put y equals negative 0.48 times 45 plus 29.41. You should get about 7.81 here. Okay, so 1995, about here, 7.81, which looks pretty accurate. Okay, you're not going to specifically be doing something like this on the SAT, but you may have to find a regression line or find an exponential curve regression for that. So if you don't have a calculator, you're going to be guessing or making good guesses. If you do have a calculator, you can do it exactly. Okay, so we're going to stop that part there, and we will continue next with solving equations.